In my previous videos, first steps in RayJack ONE and surface scattering in RayJack ONE, I showed how to set up a simple optical system, including ghost reflections and scattering from a lens surface, and I performed a ray tracing. The result looks like that, and let me very quickly review the script. So here we have the lens, the screen that catches the rays, and the light source, which is a simple collimated light source. I made a few minor changes. So one is that I increased the number of rays. The other, which is a little bit more important, is here instead of using a plane, I used a detector plane. A detector plane is a surface which has built-in functionality for analysis and which can be considered a Swiss Army knife for optical analysis. But there are many other possibilities in RayJack ONE to analyze rays. Now, here we have the scattering, and here these steps are essentially made to change the appearance of the simulation. Now, if I want to have the irradiance on the screen, I simply have to say get irradiance. And the irradiance, the flux per area, can then be computed. I do not have to repeat the entire simulation because the analysis is done in post-processing. Now you see the irradiance, and when you compare with the ray trace, you see that it mostly comes from these black rays, the nominal rays. But in order to see the rest, let me go here to a logarithmic scaling, change the minimum a little bit, and then you see that there is the nominal light plus a lot of other light. In order to understand a little bit more what's going on, I click here on hotspot analysis, select a part. Let me select here this spot and ask RayJack ONE to show the paths. Yeah, as expected, it mostly shows the nominal light paths and possibly a little bit of scattered light. So instead of using screen get irradiance in the way I've just shown, I can also add a ray filter so that we see only a selection of rays. Then we do it here by selecting out the rays that have been split twice. And once again, I do not have to repeat anything, just run the new command, and it should give me a rather flat homogeneous distribution. For good statistics, you would need substantially more rays. When I now select out here a part and show the ray paths, then you see that they essentially come from the center of the lens. When I remove the lens itself, you can easily see here the double reflection that has taken place. In the same way, I could now also select the rays that have been scattered and try to understand their optical path through the system. Furthermore, what I can do is I can show paths directly. The command is here, show trajectories. And let me use red color for the ghost rays, which I filter out using the same filter as above. And this should give me now a view of all the ghost rays, and as we've already seen, they come essentially from the center of the lens. In the optical system tree, I can get additional information, which I also could get through scripting. When I select here the screen and go to the detectors, when I click here, I have path information. There are 3 paths, no surprise. One of them has no splits, no scattering. This is the nominal light. Then we have the scattered light, and we have the doubly reflected light, which produces the ghosts. Now, very typical for this detector is that it is done in post-processing, but you can also define detectors that process the rays during the ray trace, with the advantage that the number of rays that you can use in your simulation is practically unlimited, and you can always decide which sort of detectors is more appropriate for the analysis you are going to do. Furthermore, in addition to irradiance, we can also compute other quantities like the radiant intensity, and we have a rich variety of user-defined detectors. For instance, you can easily make a time of flight detector with only a few commands. I will dive a little bit deeper into detectors in one of the next presentations. Thank you.